now we're going to get to our big topic for the chapter, the trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent, where if we think of these in terms of behavior around an angle that I don't know why the book keeps deciding to call t in this section, sine describes something like the vertical component, cosine describes something like the horizontal component, tangent describes their ratio of vertical to horizontal, cosecant is the reciprocal of sine, so it is 1 over the horizontal component. Secant is the reciprocal of cosine, so it is 1 over x, 1 over the horizontal. And then finally, cotangent is the reciprocal of tangent, so it would be the horizontal x over the vertical y. And there's actually a bit of interesting history here, because discussion of triangles is something that has been a mathematical interest basically for as long as math has been an interest. Makes sense that understanding a triangle is kind of fundamental to even the most basic engineering needs, as so many things are built around square blocks. Well, you need to know what happens in those square blocks. You're going to have a lot of triangles in there, so you need to know more about that. And interest in these functions is known to date back to the Egyptians and Babylonians thousands of years BCE. And a lot of the ideas that we get in terms of chords, which act something like these functions, dates back to the ancient Greeks still in that time frame. In particular, though, the notation that we have in terms of these functions, the original versions of it came from ancient Indian work in the 4th and 5th century, where the word they used there that I'm not going to mispronounce because I would try to mispronounce it if I did, wouldn't try to, I would just mispronounce it, was translated through ancient Arabic into ancient Latin until it finally reached English through that Latin from sinus to sine, coming from a mistranslation of a word meaning chord, where to understand where this stuff comes from, it's best to sort of think back into those terms. So if we have something like the unit circle, where on there we've got an inscribed triangle, a right triangle in particular, because trigonometry works best with right triangles, we can see that the piece that acts like sine would acts like a chord would on the circle. Remember, a chord is a line that goes from one point on the circle to another that usually isn't a diameter. Meanwhile, tangent acts like a tangent line to the circle, thinking in terms of those components, while secant acts like a secant line through the circle. Secant meaning cutting, going from the origin through to the outside and a little beyond. So, those were, in a sense, the original 3 trig functions, sine, secant, and tangent. And when you get onto calculus, those are the ones you're going to do a lot of the more intricate work with trigonometry in terms of. There's some really nice relationships that happen with those, one of which we're going to see later on with this set of videos. But those are really the big 3. And if there was any sense of justice in the world, we would have that our 3 main trig functions are sine, secant, and tangent, and then we would then have the associated cotangent, cosecant, and cosine. But thanks to Edmund Gunter in the 17th century, I believe, we're stuck with things kind of as they are, unfortunately, where those cos are meant to mean this is the one associated to it, but as a result, we get this weird mess here where they don't quite line up in the way that you'd hope they would. But when we're thinking about this, just remember that The term we have for sine, S-I-N-E, comes from the fact that ancient mathematicians managed to mistranslate a four-letter word. So we've never been working with top men, etymologically speaking. But anyway, with our idea of what these trig functions are and where they come from, we can talk about some basic examples where hopefully most of what we see in this section is not only not new, but kind of annoying that you've got to see it again. But hey, if you're annoyed that you got to see it again, should mean it's not that hard, right? Well, we'll see.